Okay, so today we're going to be solving quadratics by the quadratic formula. So the quadratic formula is written here in purple, and in order to be able to use this formula to solve any quadratic equation, you need to make sure that you've got it in standard form first. So just like when we were factoring, we needed to have everything on one side equal to 0. Same thing when you use quad formula, okay? So the opposite of b, so it means whatever is in front of b, you're going to take the opposite, plus or minus, and then you do a square root, and underneath that square root, you're going to do the b squared. Make sure you're putting that in parentheses, specifically if it's a negative number, minus 4 times a, the number in front of your x squared, and then your c, which is your constant, and then all of that is being divided by 2a. All right, so we're just going to jump down to example 1, and we're going to look at the equation that's given. We're going to put it into standard form, identify a, b, and c, and then apply that quadratic formula. What we need to do first is we need to subtract 33 from both sides, move it over to the left, so that we are in standard form. And now our value of a is 1, our value of b is negative 8, and our value of c is negative 33. We're going to use those now in the quadratic formula. So x equals, we do the opposite of b. So since b is a negative 8, the opposite is a positive 8, plus or minus square root of negative 8 squared, b squared, minus 4 times a times c, all over 2 times a. All right, when you're going to put this into your calculator, do not type this all in at one time. What you should do is type underneath the square root, do not type square root in. So type in negative 8 squared in parentheses, minus 4 times 1 is negative 33, sorry, and make sure that what you're getting is 196. So you should pause the video right now, type that in, and make sure that what you're getting is 196. And then all of that is being divided by 2. So just to clarify again, you're going to type in everything that's underneath the square root, and you get a 196. From here, this is a perfect square. So my next step would be 8 plus or minus, and the square root of 196 is a 14. And then all of that is over 2. So you're going to have two answers here. You're going to have 8 plus 14 over 2. So that's 22 over 2, meaning you get 11. And then 8 minus 14, which is a negative 6, over 2. So we get a negative 3. So our two solutions here are negative 3 and 11. All right, let's move on to example number 2. Here we're going to subtract in order to get the plus 4x minus 9 is 0. We're going to identify our a, our b, and our c. And then we're going to apply those into the quadratic formula. So x equals, the opposite of b is still b is positive, so the opposite would be negative 4, plus or minus 4 squared minus 4ac all over 2 times a. So again, what you want to do is type in everything that's underneath the square root. Okay, don't type in the square root, and what you should get is the square root of 52 all over 2. Now, square root of 52 can be simplified. There's a perfect square factor there. 4 goes in 13 times. So this will be negative 4 plus or minus 2 square root of 13 all over 2. Okay, so a little bit different than number 1 because we don't come out with nice whole numbers, but we can still simplify this because 2 can divide both 4 and 2. So you can only divide this 2 if it can go into each of the 2 terms in the numerator. Okay, so 2 has to divide the negative 4, which is a negative 2, plus or minus 2 over 2 is a 1 in front of the square root of 13. And then we leave this alone. You don't have to write it as 2 separate answers. It's negative 2 plus or minus the square root of 13. Okay, moving on to number 3. We're going to have to do points here in order for us to get this standard form. So we're going to subtract 2x from the 19x, and then we're going to add 1 to the 4. So we'll end up with 6x squared plus 17x plus 5 is 0. So our A is 6, our B is 17, and our C is 5. Going ahead to the quad formula then, x equals opposite of B plus or minus square root of B squared minus 4AC all over 2 times A. X equals negative 17 plus or minus 17 squared minus 4 and 6 times 5 is going to leave us with 169 underneath the square root. And that will be divided by 12. We got another perfect square here. So negative 17 plus or minus that's a 13 all over a 12. Okay, don't leave it like this. We're going to have to simplify it like we did in number 1. So we have 2 answers. We have negative 17 plus 13 divided by 2. This will be a negative 4, sorry, that's 12 over 12, which will be negative 1/3. And then negative 17 minus 13 over 12 is negative 3 over 12, which will reduce to negative 5 over 2. So our solutions here are negative 5/12 and negative 1/3. The quadratic formula will work for any quadratic equation that's in standard form. So you can see in each of the problems, numbers 1, 2, and 3, we had to move terms in order to get it equal to 0. But once you have everything equal to 0, the quadratic formula will always work for you. Down at the bottom of the front of our notes, it says, any of the above quadratics be solved using a different method. So the other 2 methods that we've done is we've talked about factoring and we've done the square root property. So if you look at number 1, you could ask yourself, so if we think about that, negative for the base value that will add to negative 8, b. Well, negative 11 plus a 3 would work. So what you could have done here without using a formula is you could solve this by this, and then you would have had x minus 11 is 0, and x plus 3 is 0. And you would have gotten the same 2 answers. So what's going to happen when you're solving a quadratic is you're going to need to take a look at what it is when it's in standard form and then make a decision about which way you want to solve it. If you recognize that it's factorable, it's probably going to be a little bit faster than doing the quad formula. But if the quadratic formula is something that you feel comfortable with, then you can continue to use that for all the quadratics that you choose. Problem with that method being used all the time is you may end up with pretty large numbers and we look at number 3, next I skipped number 2. Let's go back to number 2. There are no factors of -9 that are going to add 4. So number 2 definitely is not factorable. We have to use the formula. You can kind of see that in the answer because you were left with something underneath the root. There wasn't going to be an answer that you could get by factoring. But if you look at number 3, you've got some pretty nice numbers here that you could have gotten by factoring as well. So let's look at that one. So what you're looking at here is 6.5, which is 30, and then you're looking to get a 17. So that would have worked with 15 and a 2. So you could have done x plus 15 and x plus 2, and then don't forget, you need to divide by that even coefficient. So each of these would have reduced. This would have reduced by 3, giving you 5 halves. And this would have reduced by 2, giving you 1/3. So then you would have had 2x plus 5 and 3x plus 1, giving you 0. Setting each one of those equal to 0 would have gotten you the same 3 answers. So just showing you that it doesn't have to be just one method that you can solve a quadratic by. We've shown you all 3 methods now. And now you need to start making decisions about what's the best way to solve. Okay, let's take a look at number 4 on the back. So what you want to do on number 4 is you want to make sure that you're putting this in the standard form. And then we're also going to add all right, so what we end up with here is k squared minus 5k plus 2 equaling 0. If we take a look at what the constant is here, that's a 1. So 2 times 1 is 2. Are there any factors of 2 that are going to add to -5? The answer there is no, so I'm going to have to use the quadratic formula. So my a, once I've had it in standard form, is 1. My b is -5. And my c is a 2. So I want you to pause the video right now, and I want you to type quad formula on number 4, and then unpause the video when you're done. Okay, so here's our answer to number 4. Again, type and you should get a 17 there. Square factor. All right, moving on to number 5. Your leading coefficient there of 3. And then I've got a b here of -12, and I've got a c of 3. So you might just want to jump right in and start the quadratic formula with an a of 3, a b of -12, and a c of 3. But I notice that they're all divisible by that 3. So it might be a good idea for you to factor that 3 out, leaving you with a 1x squared minus a 4x plus a 1 equaling 0. The reason why I think this is a good idea is because you'll be having smaller numbers in your quadratic formula, which means that if you're left with something underneath your square root here, it's not a perfect square, it'll be easier to break it down. So whenever it's possible to do a GCF of your quadratic, once it's in standard form, I would absolutely suggest that you do that. So now I've got an a of 1, a b of -4, and a c of 1. So you will still get the same answer as me, but my answer is going to be easier to simplify. So x equals, the opposite of -4 would be a +4, plus or minus a -4 squared minus 4 times 1 times 1 all over 2 times 1. So then -4 squared minus 4 times 1 times 1 is going to be a 12, all divided by 2. And then we do have perfect square factor of 4 that will go into 12 times 3 will leave us with 4 plus or minus 2 root 3 over 2. And then again, I'm going to have to break this down, but only if 2 can go into both of these, or if they could all reduce by the same number. So we're going to reduce this by 2. So 4 divided by 2 is 2, plus or minus the square root of 3. All right, let's take a look at number 7. Number 7 says, determine the exact values that make this true. So what I'm looking for is I'm looking for what value of x will make that entire function equal a -7. So we're substituting this in to what the function will equal. Then we need to put this in standard form. So we're going to add 7 to both sides. Make this 9x squared plus 5x plus 11. Now we're going to do the quad formula. So a is 9, b is 5, and c is 11. So x equals opposite of b, which would be a -5, plus or minus b squared minus 4ac all over 2 times a. So if we put this into our calculator, 5 squared minus 4 times 9 times 11 is going to be -371 underneath my square root, and all of that is over 18. We cannot have a negative underneath our square root, so this is no solution, which you can also write as no solution, the symbol, or an empty set. No solution, nothing inside there. All right, so what I want you to do right now is I want you to work on number 6. So pause the video and not unpause it until you've got your answer for number 6. All right, here's the answer for number 6. You're substituting in 4 into f of x, and then you're subtracting 4 from -10, which gives you a value of c of -14. When you substitute in your a, b, and c into your quad formula, here's what it looks like. Your 12 squared minus your 4 and your 1 times your -14 is going to give you a 200 underneath the square root. Perfect square factor by 4 is 100, which means that 200 becomes square root. All right, and then when we're dividing by 2, we're going to have to divide the -12 by 2 and also the 10 by 2 for our final answer. So I hope you guys did well there. Let's take it down to example number 8, and we're going to do that again. So take 8, substitute it in for f of x. And then we're going to subtract 8 from both sides to get this standard form. And then we've got our a, our b, and our c. Okay, pause the video again, go ahead and put the formula, and then unpause it when you're done. All right, how did you do? Did you remember to break down 72 with a perfect factor of 46 to make the square root of 72 become 6 root 2, and then also 2 divides the 4, and it has to divide the 6. All right, last one. We're going to take the -2, and we're substituting it in for f of x. All right, then we're going to add 2 to both sides to get this into standard form. And now in example number 5, we were able to factor something out of each term. We had a GCF. We don't have one here because 4 will not go into 117. We're going to have to use the quad formula with this large value of c. All right, so my a is 4, my b is 8, and my c is negative 117. So x equals negative 8 for my opposite of b, plus or minus 8 squared minus 4ac all over 2 times a. So underneath my square root, if we type in 8 squared minus 4 times 4 times negative 117, what we should get is 1936. All of that over 8. Before you start to try and break this down and make a factor tree on it, go ahead and substitute this into your calculator. Type in the square root of 1936. If you do that, what you're going to find out is it's a perfect square of 44. So then we're going to have to write both of these answers. We're going to have negative 8 plus 44 over 8. And then we're going to have negative 8 minus 44 over 8. And so here we'll have a 36 over an 8, which we can reduce each one of those by 4 to get 9/2. And here we'll have negative 52 over 8. And if we reduce each of those by 4, it'll be negative 13 over 2. So my two answers here are negative 13/2 and 9/2. All right, and that's it for the quad formula. You can go ahead on to your homework now.